In this video, we're going to start with this drawing of two squares, and we're going to use it to study arrangements of polylines that we can see embedded in the figure, like this shape that we're drawing on top in Rhino. And when we move it over to the side, we can see that it's defined by two objects in Rhino's data structure, just like the original two-square drawing. But when we use the isometric mapping in the shape machine, we can search for the specific parts we want. And it will tell us how many matches it can find embedded in the figure, in this case 4. When we find one that we want, we can select it and pull it apart from the original drawing. And we can do this for any figure that we want to see within the two-square shape. Say, for instance, we want to trace a continuous joined polyline, like this M figure we've just drawn. When we move it over to the side, we can see that it's one object in Rhino's data structure, but when we search for it within the two squares, Shape Machine will find every match. In this case, again, there's 4 matches, and when we select one that we want, we can pull it apart from the original geometry. Now, what other figures, arrangements of lines can we see within the two squares? How about this 3-lined K figure that we're drawing? We select the 3 lines and move it over to the side, and we can use the isometric mapping to search for the 3 lines within the two squares, and Shape Machine will find that exact K, of which there are 4 matches. When we select one that we want and move it over to the side, it's pulled apart from the original drawing, and Shape Machine has redrafted the figure in its maximal representation of 3 lines. Now, what about a K with a shorter leg, a kind of lowercase k, where one leg doesn't meet one of the vertices of the two-square drawing? Under the isometric mapping, we can search for that exact lowercase k, cycle through the matches highlighted in red to see that there are 8, and when we find one that we want, we can pull it apart from the original drawing and see that Shape Machine has redrafted it in its maximal representation of 3 lines. Now, what about a scaled version of the lowercase k, an even smaller one, where only one of the vertices matches the original vertices in the two-square drawing? Under isometry, we can find that exact k and see that there are 8 matches. And when we see one that we're interested in, we can select it and pull it apart from the original two-square drawing.